Hello, today we're doing surface area of prisms and cylinders. Feel free to pause the video if I go too fast. There are some shapes you might need to have some time to draw. So the first shape we're going to find the surface area of is a prism. Now before we talk about the total surface area, we actually have to find the lateral area. To do that, I'm going to draw the net of this solid. So remember, I start with my base, so this is going to be my base. And I'm going to fold the side that's closest to me down. And I'm actually going to unravel the sides. And then I'm going to unfold the top base. So it's actually going to look like this. So the lateral area is the area without the bases. So no bases. And then I use LA to abbreviate lateral area. So this is my base. And this is a base. I'm going to use a capital B to talk about the base. So then my lateral area is all of this. So the area of this shape of the net is lateral area. Okay, that whole shape is a rectangle, and remember, to find area we take the base times the height of a rectangle. Now if I take a look at the base of this rectangle, I'm talking about each edge here. This ends up being the base of that lateral area, which ends up in reality being the perimeter of the base. Okay, so that's my P, and then I take it times its height here. Which is this height here on this edge. Okay, so let's write that out. The formula for the lateral area equals the perimeter times the height. Okay, so H is height, P is perimeter of the base, so you might want to write that somewhere. No, I'll do it in green here. P is perimeter of base. The reason why we had to find the lateral area is because it's part of the total surface area, but we have to be careful here when we're using H. This H is the height of the solid. Okay, when I go to find the total surface area, I'm going to talk about another H, but it's going to be a little different. Okay, so total surface area is actually the area of the bases plus the lateral area. So to do the total surface area, TSA is what I use for abbreviation. I'm actually going to take the lateral area, so the area of all this here, and to do that, it's perimeter times height. And I'm going to add it to the two parts of the net we haven't found yet, and that would be the bases here. So I'm going to add it to the area of the bases. So because I have two of them, it's 2 times the area of a capital B. Okay, capital B means area of the bases. It doesn't mean like a base. So the reason why we use a capital B is my prism could have any shape as its base. You know, I could have a triangle, I could have a pentagon, any polygon really. So we use a capital B just to say, hey, I have to find the area of the base. You have to identify the shape of the base first, and that's how you're going to find the area of the base. For this shape, we have a square or a rectangle as the base. So when I find b, I'm just taking base times height because of the shape that I have here. Okay, and when I use this h, I'm talking about the height of the base. So that's where it gets a little tricky. I'm talking h here and b here. Lowercase b meaning the distance here. Okay, so uppercase B means the area of a base of this whole base down here, and little case b means just the length right here. So make sure you know the difference. Okay, so that's how you find surface area with a prism. We will do an example in a minute. I'd like to talk about surface area for a cylinder first. Okay, so this is a cylinder. Okay, so remember lateral area is the area without the bases. So all the way around the cylinder is the area I'm trying to find. So again, I'm going to draw its net to help me. So my first base is a circle. And then it actually opens up and all the way around, if I lay it out flat, is a rectangle with another circle base. Okay, so again, my lateral area is this space here. Okay, and to find that lateral area, again, I'm going to, it's a rectangle when you look at the net, so we're going to take this times the height, h. So the height here is what we're using for the lateral area. But when we talk about the base of this rectangle, we're actually talking about all of this. So it ends up being the circumference of the circle because it wraps around the base. So this is actually the circumference. So C equals, 2 pi r. Okay, so when I find lateral area of a cylinder, I'm going to take the circumference 2 pi r, and I'm going to multiply it by the cylinder's height. Okay. Anytime we use height with lateral area, we're talking about the actual vertical height that creates, a 90-degree angle. So that might be one way to distinguish that. It definitely gets a little confusing when you're talking about prisms. All right, so total surface area is still going to use that lateral area because I need the area of this, but I also need the area of the bases. So it's going to still have that 2 pi r times h, but then I have to add the area of the bases. And in cylinders, the bases are always going to be circles. Unlike prisms can have any type of base shape, but in cylinders, it has to be a circle base. So I have to find the area of those circles. And the area of a circle is pi r squared, and I have 2 of them. So in my total surface area formula, it's going to be 2 times pi r squared. And that's how I find surface area of a cylinder. All right, so let's do a couple example problems to try out these formulas. The first is a prism. So we're going to find total surface area. Total surface area of this prism. Okay, so remembering that the TSA for a prism is equal to the perimeter times the height of the solid plus 2 times the area of the bases. That's why it's capital B, because it's the area of the bases. So I have to find those things and put it in. So first, my perimeter. Remember to find perimeter. It's adding up all the sides. And down here I have a square. I know that because I have tick marks. So my perimeter is going to be 5 plus 5 plus 5 plus 5, or 4 times 5, which is 20. So over here, my total surface area, I need to put perimeter, the height, And the area of the bases, my perimeter is 20, so I can put that in. And then I need the height of the solid. Remember, that height is talking about this here of the 3D solid, which is 12. And then I need the area of the bases. So I look at one base at a time. My base is a square. It has 5 and 5. Okay, the area of the bases is going to be base times height since it's a square. The base of the square is 5 times the height of the square is 5, not 12. Remember here when you're looking at the capital B, you're focusing on the base and nothing else. Okay, 5 times 5 is 25. So here I put 25, and then I can just multiply that all together in my calculator and add it. And I get 290, and I'm going to put units cubed, or squared, sorry, squared. Because we're doing area, so it's still squared. They don't give me units, so I'm going to use the U. So that's my answer. All right, so that's how you find a prism. Now, if my base was a triangle, here I would use 1/2 base times height instead, because the shape of the base is a triangle. So remember, this is going to be determined by what shape you have as your base. All right. So let's try another one, another prism. So this prism, I'm going to find total surface area of this prism. My formula is perimeter times the height of the 3D solid plus 2 times the area of the bases. Okay, so first let's find my perimeter of the base. Okay, so my base is a triangle. It's actually equilateral because it has tick marks. So it's 4 all the way around. So my perimeter is going to be 3 times 4, which is 12. I'll put that there. And then the height of my 3D solid is 8. So that goes there. And then I have to find the area of the base. Now my base is a triangle. So that's going to be 1/2 base times height. My base is 4, but I don't have the height of my triangle. Remember, height has to be created with a 90-degree angle. So remember, in an equilateral triangle, when I draw that altitude, that height there, it actually breaks this into 2 pieces. So this is a 2, and that's a 4. So I could just use Pythagorean theorem. I could also use my 30, 60, 90, because if you remember an equilateral, it's also equal angular. So whatever you want to use, you can. So it's going to be 2 squared plus my height squared equals 4 squared. And when I solve that for h, I get about 3.46 is what h equals. So over here, I'm going to multiply by 3.46. So 3.46 times 4 divided by 2. And that is 6.92. The area of my base is 6. Oh, I should have left myself more room. Okay, and then I just put that in my calculator. And my answer is 109.848 units squared. Okay, and again, I could just ask you to find lateral surface area, lateral area, sorry. If I do that, you're just doing this part of the formula and you're not doing this because lateral is the area without the bases. All right, there's one more example I want to go over. It does have a cylinder in it, so we can go over how to do a cylinder, but it also is a combo problem, which means it's two solids put together, so it takes a little bit more work. The first thing I do when I have a combo is I actually write down all the outside of the shapes, and that helps me kind of come up with a plan of the math that I need to do. So remember, surface area is the area outside of the shape. So I take one shape at a time. So let's look at the cylinder. On the cylinder, you have this top base here. Okay, so we're going to do the base of the cylinder. I have to find that area. Plus, the thing that's on the outside is the lateral area all the way around the cylinder, all the way around, is exposed to the air, or the outside world. I'm going to erase that stuff now. Okay, so we're going to have to find those two things to find the total surface area of this combo problem. The thing is, though, this base down here is not exposed to the air. If you think about this in real life, that base is touching the prism, the cube, and it's not exposed to the air, so I don't need that base, so I'm going to skip it. Okay, what I do need is I need the base of the cube or the prism, this base down here. So I'm going to add the base of the prism, the area of the base of the prism. Let's scoot this over a little. Sorry, technical difficulties here. Trying to make more room. All right. So the other part of the prism that's exposed to the air is its lateral all the way around. So I need to add the lateral area of the prism. Now there is a unique part of this problem is the top base of the prism isn't fully exposed to the air, but pieces of it are. So like this piece, and this piece back here are all exposed to the air. So I actually have to find the areas of those little pieces. Now, what I have there is I have a square, and I have the base of the cylinder, and I need to find the area of the shaded, essentially, so all of this. Okay, so to do that, if we remember from our last unit, I actually take the area of the outside shape and subtract the area of the inside shape. So over here, when I find the area, I actually have to take the area of the base of the prism, and I have to subtract the area of the base of the cylinder, and that will give me those little pieces that I need. So there is quite a bit of work on this one. I just write out my plan of all the pieces I need to find of the 3D shapes, and then I find each piece and add it all together. Okay, so I'm going to start first with the base of the cylinder. Okay, so it's a circle, and I need to find the radius. Okay, so this length here, let me erase some of this so we can talk about how to find the radius. So this length here is 6. And if I were to move it, it's 6 still inside here. So when I move it up across here, it is still 6. So that makes the diameter 6, which then makes the radius 3. So remember, area of a circle is pi r squared. So pi, my radius is 3 squared, so I have 9 pi. Right, and I'm just going to keep it there until I'm ready at the end to add it with everything else. Next, I need to find the lateral area of the cylinder. Remember, to find lateral area, it's going to be the circumference 2 pi r times the height of the 3D solid. Okay, so again, my radius is 3, and the height of the cylinder is 10. Okay, so when I multiply the 2, the 3, and the 10, I get 60 pi. Okay. And then we have to find the area of the base of the prism. Okay, it's a square because I have all the tick marks here. So that's just base times height, so 6 times 6. Okay, so this base times this height, because I'm just focusing on the base of the prism, that gives me 36. And then the lateral area of the prism. Okay, lateral area of the prism, remember that's perimeter times the height of the prism. So my perimeter is all the way around here. It's all 6, so 6 times 4 is 24. And the height of the prism is also has a tick mark, so the height of the prism is 6. So I take 24 times 6, and I get 144. All right, and then now the fun part, where I have to take the base of the prism and subtract the base of the cylinder. What's cool about doing all the other parts before this one is that I already found these values. Okay, so the base of the prism is right here, and it's 36. So I can take 36 and subtract the base of the cylinder, which is right here, and it's 9 pi. So at this point, now what I have to do is I actually have to take all these answers that I got. Oh, that's not an answer. All the answers here. And combine them together. You can do this in your calculator and put pi and get a decimal. I'm going to show you how to do it with combining like terms, because next year you're going to be working with pi a lot. So I don't expect you guys to do this when we're doing work online, but I just want to show you how to do it so that next year you're not so confused. Anything with pi on it, think of it like, think of this like 9x. I can only combine it with other numbers that also have x, or in this case, also have pi. So when I combine those, I'm adding, 9 and 60, I get 69, but I have to subtract 9 again, so I'm left with 60 pi. So my answer is going to have 60 pi in it. And then I'm combining all the regular numbers, the numbers without the pi, which is the 36 and the 144. And when I add those together, I get 180, so I add 180. So if you want to be exact and write your answers exact, you would write it as 60 pi plus 180 units squared. Or you put that all in the calculator, use your pi button, and get a decimal. Either's fine. Just again wanted to show you, because next year you're going to be working with pi, and you're not going to be able to put it in the calculator because you're not finding area next year, you're using it with trig. And that's how we find total surface area of cylinders and prisms.